Well, hello and welcome to your Unit 6 Lesson 5 notes on square roots, where a tip to be square. By the end of the day, you'll be able to estimate square roots and simplify radicals. So we're talking about squares today. When we talk about a square number, to square a number means to use that number as a factor twice. So if we wanted to find out what is, 5 squared, well, that's 5 times 5, which is 25. Or if we wanted to find out what is 3 squared is 3 times 3, which is 9. So that's exciting. That's a square. The idea being, if you have a square with that length, like if it's a 3 by 3, how many units is inside of that? There are 9 little guys inside there. 3 times 3 is 9, because you make a square. Okay, anyway. So if you want to go backwards, the opposite of a square is finding a square root. For example, if you're like, hey, what number times itself twice makes 9? You go like this. You say, okay, well, what is the square root of 9? Well, what is this? 9 is something times itself. And what is that thing? Well, 3 times 3 is 9, so it's 3. The square root of 9 is 3. Okay, that's why. Instead of just saying square root all the time, we use this symbol, a radical, because he's so cool. He's a radical. So we call him a radical sign. And that means this is square root. So when we see this guy, radical n, it means the square root of n. And then the n is the guy underneath the square root. We call him the radicand. Fun fact, the radicand is the number underneath a square root. Cool. So here's your key idea, your definition. Square root of a number is one of its 2 equal factors. That is, if the square root of a is b, that means b times b equals a. We just saw this as, if the square root of 9 is 3, it's because 3 times 3 is 9. Like that. There you have it. Okay, but why does this fit into our little exponent unit? Well, that's because the square root of a number is the same thing as that number to the 1/2 power. So that's exciting. That's supposed to go up here. Weep. Okay. So for example, the square root of 9 is this 9 to the 1/2 power, which is 3. Because if you went the opposite way, 3 squared is 9. Okay, cool. Here it is. What is the square root of 49? Well, I need to think of 2 numbers when I multiply that number times itself, and I get 49. What number, when multiplied by itself, will give me 49? Well, 7 will. 7 times 7 is 49, so the square root of 49, 7. Next. What number? We want to find the square root of 121. So what number times itself will give us 121? Well, 11 times itself, they look like pig noses, will look like 121. Will in fact be 121. So the square root of 121 is 11. They asked us for the negative square root, so that's negative 11. Cool. Now we can put this to good use by multiplying them together. This says the square root of a product is equal to the product of the individual square roots. So you can spread your radical symbol to both of your variables. Square root of AB, square root of A times the square root of B. We're going to put this into practice to help us simplify radicals. What I'm going to do is I'm going to do one, I'm going to tell you what we did, and then we'll do another one. So let's look at 225. I want to break up 225. I know that in my head, 225, that's divisible by 5. So when I divide 225 by 5, I get 45. Okay? So I can say that the square root of 245 is the same thing as the square root of 5 times the square root of 45. But I can keep going. In fact, I want to break up 45 even more. 45 is 5 times 9, but I'm going to break up 9 even more. 9 is 3 times 3. We can't break these guys up anymore. So the square root of 225 is the square root of 5 times the square root of 5 times the square root of 3 times the square root of 3. Boom. Okay, now we've broken that all up. In fact, I misspoke. I should have had these all under one big thing. My bad. Okay, and now, so what did we do? We broke the radicand up into what are called factors. So how can we split him up with multiplication? And now, because we're dealing with squares, we want to group these guys together in pairs, because these pairs will make squares. So that's the same thing as the square root of 25 times the square root of 9. And now we can use our multiplication guide to put into practice. So we grouped our factors into pairs, or because that's the same thing as squares, it's the same kind of deal. Okay. Now, we just used the product property of square roots. There will be another one, I'll come back to it. We use the product property of square roots to break this guy up into 2. So the square root of 25 times 9 is the square root of 25 times the square root of 9. But this is going to be really convenient because guys, guess what? Do you know what the square root of 25 is? It's 5. Do you know what the square root of 9 is? It's 3. Do you know what 5 times 3 is? It's 15. So tracking back all of our equal signs all together, that tells us that the square root of 225 is in fact 15. Boom. And you can, while I struggle, you can go ahead and plug that into your calculator and it will prove to be true. Okay? So what did we do? We broke up our radicand into all its factors, and then we grouped them into squares, 25 and 9. Then we used the product property of square roots, and then we simplified each radical. That is, we took our square root of 25, simplified that up. Took our square root of 9, simplified him up. Okay, now let's do it again with 324. We're going to break 324 up into its factors. I see that 324 is divisible by 2. It's also divisible by 4. So we have 2 times 2 times 18. I need to keep breaking 81. 324 is 4 times 81, 2 times 2 times 81. I need to break up 81 even more, giving me 1, 2, 3, 4 threes. So after we've broken it up onto all of our little pieces, now we need to put these guys into pairs. So one pair is a 2 pair, a 3 pair, and another 3 pair. So that's the square root of the square root of 4 times 9 times 9. Guys, check it out. 9 times 9 makes another pair. So that's the square root of 4 times 81. How fancy was that? Now we can break this up with our product rule, giving us the square root of 4 times the square root of 81. Guys, what's the square root of 4? It's 2. And guys, what's the square root of 81? It's 9. 2 times 9 is 18. So the square root of 324 is 18. How great is that? So that's how to simplify a radical with factors, but we can also use the quotient property to do the same thing. Remember, quotient means divide. So the square root of a quotient of a number divided by a number is equal to the quotient of the square roots. So what's great is square roots behave exactly like you want them to be. If you've got a square root with division, you can break it up into a division of square roots. I'm going to do one more as an example. You don't need to do a whole bunch. So if we want to simplify the square root of 36 over 4, that's the same thing as the square root of 36 over the square root of 4. The square root of 36 is 6. The square root of 4 is 2, which is 3. Or, you know that 36 divided by 4 is 9. And the square root of 9 is 3. Okay, anyway. So let's say you have a gross number and it doesn't work out to something really nice like 3, and you just need to estimate it. Well, there are two tools you need to estimate a square root. One, your brain. I'm just kidding. One, a list, and then also a number line. But what list do you need? You need a list of perfect squares. And here it is. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. I think that's all we'll need. Yeah, that's all we'll need for this case. Okay, these are all our perfect squares. So hang on to them, put them in a safe space, safe place. Oh, hey, look, number lines, that's convenient. So what we need to do is we need to find perfect squares that are nearby. So we find 22 on our number line and we mark 22 down. And then we need to find other perfect squares that are nearby. Well, 22 is between 16 and 25. So those are our perfect squares. Oh, look, 25 is already there. I'm going to write it big so you know we're paying attention to it. Okay, so here, as you can see on my number line, the square root of 22 is between the square root of 4. I'm sorry. Haha. Thinking too fast. The square root of 16 and the square root of 25. Cool. Now, guess what, guys? I can simplify this. What is the square root of 16? It's 4. This stays the same. What is the square root of 25? 5. So the square root of the square root of 22 is between 4 and 5, somewhere-ish. But if you look at the number line, what is it going to be close to? I should have done this in gray. Okay. Remember, the square root of 16 is 4. The square root of 25 is 5. So is the square root of 22 going to be closer to 4 or 5? It's going to be closer to 5, actually, because 22 is closer to 25. So we're going to say the square root of 22 is approximately 5, but it is a little bit less than. Isn't that cool? Let's do one more. Same process. 130. What squares is that between 121 and 44? So let's mark those on our number line right here. We have 121 and 144. And what are we looking at? 130. So that tells us that the square root of 130 is between the square root of 121 and the square root of 144. But what's the square root of 121? That's 11. And what's the square root of 144? That's 12. So the square root of 130 is between 11 and 12 somewhere. Cool. What's it going to be closer to? Well, since it's closer to 121, the square root of 130 is going to be closer to the square root of 121, which is 11. It's not as close to 144, so it's going to be about 11. It's approximately equal to 11. Isn't that cool? So cool. Well, this is important. Remember, quotient of a square root is the square root of a quotient is the quotient of a square root. Remember that the product, this is my favorite, I love this one. The square root of a product is a product of square roots. And yeah, square root means it's the backwards square. Hey, have a great time in your homework.